Hello, everyone, and welcome to TechScript. Today, we will talk about how network communication takes place with the help of OSI model and TCP/IP model. So, without wasting any time, let's start. So, we all are aware of the OSI model and the TCP/IP model. So, over here, I'll be using this topology over here to actually explain how the network communication takes place. So let's get started. Um, let's take an example wherein this computer has to. You are sitting on this computer. Let's take this example that you are sitting on this computer or sitting in front of this computer, and you want to go to Amazon.com and you want to buy something, right? So when you go to Amazon.com, you select an item to buy and you click on buy now. So that actually becomes your data. So let's assume the item that you want to buy is for 50 rupees. So that 50 rupees will actually become your data. So that will be the data inside the packet. So we'll see how the packet is formed as well in this video, right? So all the applications that are aware, for example, Chrome and Internet Explorer, all of these applications lie on application layer. And then the information is passed down to the presentation layer. So as we know, at presentation layer, two things happen. The first is it standardize the format. I mean, application knowledge, uh, in accordance to the application knowledge, uh, the standardization happen so that the server and the client are able to understand the data that they are going to transmit. So standardization takes place. That's the first thing that happens over here. The second thing that happens over here is generic encryption. Some sort of encryptions also takes place at this layer. Then the information is passed down to the session layer. Of course, when you hit Amazon.com, some sort of connection was established from your computer to the Amazon server, right? So those sessions are created, deleted, or maintained at the session layer. However, no network concepts, no network technologies are involved. Hence, the TCP model, being far better, is able to combine these three layers into one layer, which is application layer. Right. So, what we see is, with the help of the layers, we can clearly see that uh, we have a data uh, that is generated, which is supposed to be sent to this server over here. Right. Now comes the network bit of the communication, that is the transport layer. Transport layer will insert its own header in front of the data, right? And what will happen, there are two choices made over here. Either a TCP or a UDP protocol will be chosen, and the second uh, choice made over at transport layer is that of port numbers, right? So however, the important thing to note over here is that it's not the computer that actually dictates this choice. It is the application itself that dictates the choice, that what protocol is supposed to be used and what port numbers are supposed to be used, right? So in case of Chrome, if you're using Chrome or any other browser and you're browsing Amazon.com, of course it will use port protocol as TCP, and port number will be 443 in case if it is HTTPS, right? So we will have in our example, we will have TCP header. TCP header will contain the port number, which will be as follows. So destination port will be 443, and the source port will be something random, let's say 1024, right? So now this is all what happens at transport layer. Now we move on to the network layer, or in terms of TCP/IP model, it's known as internet layer. At network layer, IP addresses come into the picture. Now, of course, uh, this computer over here will have some sort of IP address, of course, right? So let's say the IP address over here is 10.10.10.3, right? So that will be the source IP that will be inserted over here in the header. That will be the source IP. What will be the destination IP? Of course, the destination IP will be of this server. Let's say it is 192.168.1.3, right? So that will be the destination IP over here, 192.168.1.3. Oh, sorry, the destination IP is here, right? I have a separate space for that. Right, so source IP and destination IPs will be inserted in the header, right? That is exactly what will happen at network layer. And then we will move on to the data link layer, where the MAC addresses come into the picture, and the source MAC will be of this computer, right? Let's say the source MAC is ABC and the destination MAC is DCB. So the source MAC will be ABC over here and DCB. Now this is what a complete say a packet will be generated, that you see over here. This complete packet will be generated. It will be sent on to the physical media, and it will reach to this server, and this server will rip open all these headers, will get the data, and then will perform the same process again according to the OSI model. And the response to your query, wherein you want to buy something, will be sent back to your client, right? So this is how the communication happens or takes place. Let's go into a bit more detail, but let me clear few things over here, my scribbles, so that I make a bit more space for you, for myself, in fact, to write. Just bear with me. Right. So let's continue to see how actually this packet will go from this computer to this server. Now, when this packet will be generated by the computer, the very first thing that will happen is an ARP request will be sent to fetch the uh, destination for the local network, right? So this is the local network. This computer will send a request to this default gateway, and this packet will reach over here, and then the communication will happen hop over hop, and at each and every hop the source and MAC address will change. How? Let's have a look. So now this computer has to send some information to this server. So what it will do is, it will ask, where is this IP address, right? This IP address, of course, is not on the same network. So it will ask for the router, who knows, this router through its routing table knows the path towards this server. It knows the path towards this server. Of course, it's part of routing concepts that we will cover in our upcoming videos. But for the time being, you should know that routers have routing table and they know the path towards the destination, right? So when this packet will be generated by the computer, the source MAC will be ABC, as we know, but the destination will not be DCB. The destination MAC will be of this router, this interface of the router, right? So the packet, so as I said, it's a layer 2 communication. Layer 2 communication is used to communicate within a given network, right? So there are three networks over here. So within the network, the layer 2 communication takes place. So when the packet will reach over here, this router will now rip off the MAC addresses, and now the source MAC will be of this interface and the destination MAC will be of this interface, right? So now the new packet will have all of, let me change the color of my pen. The new packet will have all this information over here, all this information except this one will change. Now the source MAC will be, as I said, this interface, and the destination MAC will be of this interface. And similarly, when the packet will leave router 2, it will have a source MAC of this interface and destination MAC of this interface, right? So this is how end-to-end communication takes place of packets. That's it. I think it's very simple. Yeah, another thing that we left. This computer will also add in the end another thing which we call CRC, or the random checksum check. Uh, so it's kind of a little hash to maintain the integrity of the packet. We don't want the packet or the data to be manipulated, right? So what the computer will do, it will add the redundancy check uh, to the packet, and this redundancy check will be calculated by the server again to find out whether the information of the packet has changed or not. So I'll give you an example. Let's say I want to send a data that is ABC. Now I can put an integrity or a redundancy check, and I can calculate a redundancy check value. Let's say that comes out to be uh, I and J, right? So once this information reaches its destination, the destination will again take this information and generate a redundancy check value. Now the redundancy check value should again be I and J, right? If it is not, then it means the packet was manipulated or changed on its way when it was being transferred from the source towards the destination, right? So it is another way of kind of uh, making sure that there is no manipulation of the packets, right? Yeah, that's it for today. I hope this information and this video is informative to you. Don't forget to subscribe the channel, hit the like button, and if you want to have more information, more videos on different topics, you can leave the comments over there, and I'll try my best to make a video on any specific concept or technology that you want to hear about. So again, thank you very much, and don't forget to subscribe the challenge. Have a good day.